All right, so coming into Unit 3.4, I just want to kind of give like an introduction video to start us off, to kind of give you a perspective. There's a couple of decent videos for when you're doing the polynomial or the synthetic division, and so I'll leave the videos from the textbook company, and then if you need any resources, just please reach out and let me know. Where we're going and where we're building to is this concept of if I give you a polynomial, so in this case you're kind of reviewing from the previous section, this would be a linear, this would be y equals x to the first power because I crossed the x-axis one time. I have one real zero. And this guy right here, this would be y equals x squared because I have two real zeros, or I cross the x-axis two times. And before I go any further, let me make it something here, and kind of a statement. The words solution, x-intercept, zeros, and there's another one I'm not thinking of off the top of my head. They're synonymous. They mean the same thing. When someone says find the solutions to this equation, we're looking for the places that crosses the x-axis. When someone says find the x-intercept, then we're looking for the places, of course, where it crosses the x-axis. If someone says, what are the zeros of your polynomial, then they're saying, where does this cross the x-axis? Could be the y-axis too, but that's besides the point. All right, so here we go. Next one, this would be a y cubed. And so that means that it should have 3 zeros. Now, at this point, we're getting more advanced and we're talking about this, and it doesn't mean that we have to cross the x-axis 3 times, but we're going to have 3 zeros. Some of them will be real, some of them will be imaginary. We'll get onto that concept later. And the last one, this will be y equals x to the fourth because it has 1, 2, 3, 4 x-intercepts. Therefore, it has 4 real zeros, and then we see the correlation. 4 x-intercepts, degree of 4. 3 intercepts, degree of 3. 2 intercepts, degree of 1. 1 intercept, degree of 1. So in this case right here, you don't have this handout, so you could create it and draw it. You could watch this video and jot down some notes. But there's some vocabulary here that we want to feel comfortable with when we're looking at polynomials. And so this is a handout that I've had in the past for my face-to-face class. And I'm just going to use it with you as just kind of a guide. So what is the degree of this polynomial? Well, the first thing we need to think about with the degree is we need to put it in order. So we put it in order, descending order, from the largest exponent to the smallest exponent. Therefore, that means my degree is 2 because that's the largest exponent. The name by degree doesn't really matter, but we'll go ahead and go through this. Like, I'm not going to ask you a question is what I'm saying on the test. It says, what is the name of this polynomial by degree? This would be quadratic. The leading coefficient is important because we're going to discuss this whole idea of, we're going to discuss this whole idea of if your leading coefficient is positive or negative and how the behavior of your graph is. And so knowing the leading coefficient and knowing that it's -8 is actually very important. Coefficients, these are just for conversation purposes. One thing that I do want you to think about is that this guy has 3 terms. 3 terms, and so our terms are -8x squared, +4x, and -7. Those are our terms. The terms have the coefficients. So -8 is the coefficient of the first term, 4 is the coefficient of the second term, and then the third term here is special because it doesn't have a variable, therefore it doesn't change, so we call it a constant value. This guy has 3 terms, 1, 2, 3. And so we call this trinomial. Move down to the next one, and at this point, once we get going, remember you can always press pause and kind of practice yourself, and then come back to it. On the second one, we need to put it in order, and you can do this mentally or you can do it physically. But mentally we put it in order, and we see that our largest exponent is a 4. This is a 4th degree function. Therefore, it would have four zeros. We don't know if they're real or imaginary necessarily right this moment. And then this would be called a quartic. Okay, not terribly important. Like I said, that was not a terribly important conversation. Our leading coefficient is positive 9. Our coefficient is 2. And we don't have a constant term. I'm not going to put an X like that. That might be confusing. And I'm just going to write none. There's not a constant term on this one because there's not a number that doesn't have a variable. There are two terms, so we call this binomial. The next one, our degree is, well, it's understood. There's an understood 1 right there. So this is called a linear function. The leading coefficient is negative 2/3. I don't have, in this case, any other coefficients. I just have a constant. I have two terms, so once again, we call that a binomial. The next one, it's already in order, in descending order, so our degree is 3. We call this a cubic. It's an I. Our leading coefficient is negative 3. We do have some coefficients this time. We have a coefficient of 3, and then we have a coefficient of negative 5. Our constant is 9. We have 4 terms. And the way this works is that when you name it by the number of terms, we actually, when you get to 4, we just start calling it a polynomial. So it doesn't become anything special. So anything past 3 becomes just a polynomial in general. Go down to the next one here. Our leading coefficient, I'm sorry, our degree is 5. We call that a quintic. The leading coefficient is negative 5. We don't have any other coefficients, and we don't have a constant. There's one term, and we call that a monomial. Okay, we put it in order, in descending order, so 2x cubed plus 4 over x minus 2, and we stop because this isn't even a polynomial. Because of this guy right here, this wouldn't even be considered a polynomial, so we won't even answer these questions. Let me see, let me apologize. So not a polynomial. Okay, because of that rational or reciprocal little piece right there that we've seen in previous situations. All right, the last one. So we look at it and we're like, okay, well, that's kind of weird. It doesn't have an exponent. So, you know, like we're like, well, what degree is that? Well, let's just do this first. Let's just establish that this thing is a constant. It does have one term, so it is called a monomial. It doesn't have a coefficient. It doesn't have a leading coefficient. And to help you understand why I'm about to write this degree is equal to 0 is if I rewrote this for you. If I rewrote this as 3/5 x to the 0 power. So remember, we know that anything to the 0 power, and test on your calculator, anything to the 0 power is equal to 1. So essentially what I'm saying right here is I'm saying 3 over 5 times 1. But what it does is it helps you remember why the degree is 0. And this guy is just called a constant. Okay, so number one thing to remember here is that as we close this out, this column right here is important. Okay, the degree. Being able to identify the degree of a polynomial. All right, being able to identify the leading coefficient is important. And then from there, these other situations are just kind of some vocabulary review to make you comfortable and to basically speak the language of math. All right, so hope this video kind of helps kick off. Like I said, use the videos that come with the textbook or inside of my math lab for the other synthetic division problems.